Good day, students. So we're still looking at completing the square to write a quadratic in vertex form. But for this, or in this lesson, we will be going a step further. We will be looking at how to complete the square when our a is not equal to 1. What am I saying? So here are some things to recall. So remember, this is the general form for a quadratic expression where A, B, and C, there are some numbers. All the ones that we have done, all the assignments that we did with completing the square, if you should go back, you would realize that our A is always 1, meaning we always just have x squared plus some bx, so whatever value goes here. But our A was always 1. And from that, when our A is 1, we said that to write it in binomial square, we would normally have x here plus this d represents some number all square, right? And then from our previous assignments, these are some rules that we learned. So just to recall, the value that completes the square. So that value that we use to complete the square when we were modeling with the algebra tiles, we remember we said it is always half of b and we will square it. So this is how we would find that value, or how many units it takes to complete the square. How to write in binomial square. So once this is a perfect square trinomial, that is when you would write it in this form. And then this d right here is always half of whatever b is. Now remember, you cannot do this unless this is a perfect square trinomial. And you would realize in a perfect square trinomial, this last value, the value that completes the square, it will always be a square number. That's one way you can tell. Whatever the value is that completes the square is always a square number. And as you can see, anything if you have some number and if you square it, you will always get a square number. All right? So with that said, let's look at an example. Complete the square to find an equivalent expression. So in this problem, let's talk about our A. So we realize that our A in this problem would be 1, even though it is not written. Our B in this case would be 4, and our C would be 10. And we're asked to complete the square. Now, many of you may see this 10 right here and say, but the square is already complete because there is 10 there. No, we are not sure if it takes 10 units to complete the square. It could have taken more or less. This was given to us. So how would we do a problem like this? So remember, we were given, unlike the others that we did, we were just given like this part. We were just given the first 2 terms. We weren't given the C, and we have to find it. The same thing we're going to do here. This 10, as a matter of fact, this 10 is not a square number. So this is not a perfect square trinomial. So we have to ensure that we make it a perfect square trinomial. All right? Following? So remember the assignment that I gave you where I said that if you have enough tiles to complete the square, and if you have leftovers, you're going to add a plus, or if you need to borrow, you need to have a subtract. It could be this case. They could just give you 10 units. Maybe it takes more than 10 units to complete the square. Or maybe it takes even less than 10 units to complete the square. But just like imagine you're tiling the floor and they give you all this. It doesn't necessarily mean that this 10 unit right here is what needs to complete the square. So we have to ensure that we know exactly how many units we want to complete the square. So for a problem like this, what we would do, because we normally work with just this part. So we're going to turn this into an equation. So by writing, so we're going to have x squared plus 4x plus 10 is equal to 0. So now this is an expression up here. This one is an equation. So what we want, because we just want to focus on the part that has the x, like what we have been doing before. So we're going to take that constant 10 and put it on the other side. So we are putting it one side. So what would I need to do? I would need to subtract 10 from both sides, right? So if I subtract 10 from this side, I also have to subtract 10 from this side. You agree? It's an equation. So that is going to left us with x squared plus 4x is equal to, so this cancels, minus 10. So now we have this over here by itself. We're now going to focus right here. And we can just use this. You can choose to do algebra time, but we're moving away from it. So now we have this. We need to know what is that value that should go here, that c that should go here, that will complete the square. If we use this, we say that c, and the c I'm talking about is a value that will complete the square. It is always going to be half of b all square. So we can say, let's write x squared plus 4x. And then we need to add that c value right here that it will take to complete the square, is equal to minus 10. Good? So how do we find that c? If we go here, it is half of b all square. So side work, b is 4. So it's going to be 4 divided by 2, half of 4. And then we're going to square it. And this works out to give us what? Half of 4 is 2, and 2 squared is 4. So you realize we actually need 10 units to complete the square. Sorry, my bad. We need 4 units to complete the square, not 10. 4. So this right here, this is the value that we would need. This is the amount of units we would need to complete the square. And if you look, 4 is a square number. All right? So, but there is one thing though, because we add this to one side. How much, so if we have 10 units overall, right? How much do we need to complete the square? We would need just 4. So how much would we have leave back? It would be 6. So to show that, we would say if we add 4 to one side, we also have to add 4 to one side. Let's go again. Because we add this, because this wasn't there in the original problem. We add it to one side. Which means if we add it to one side, we have to also add it to the other side. So you realize oops. And minus 10 plus 4 gives us minus 6. Good? So you realize we have 6 left over. And it kind of makes sense because how many units we had initially? We had 10, but we only needed 4. So we know we're going to have 6 left over. Probably you may be wondering why it is a minus 6. It's just because we take it to the other side. If we were to take it back to the side where everything is, it would be a plus 6. Okay? So now that we have a perfect square trinomial, which we are now used to, we need to write this as now, this part now we always write as a binomial square. So we know that this we're going to have some x. Now they are all positive, so I'm going to put plus here. And then we need to know what value goes here, what d. What is the d right there? Right? And then we would square that. To go back, how do we find the d? The d is always half of b. So again, b is 4. So the d value would be 4 divided by 2, which is equal to 2. So we know that right here is 2. And then equal to minus 6. All right, so we're going to put everything to one side. So we're going to just have x plus 2 all square plus 6. And you can leave it like that, equals 0. Or I leave it here. So right here we have it in vertex form. So this is saying that the graph would shift to the left 2 units. And this plus 6 is saying the graph will also shift up 6 units. And that's how we would complete the square. So you just to recap with this one. When you're given this, don't assume that this is a value that completes the square. You have to be certain, and to be certain, you have to find it yourself. So the first thing we did was we set this expression, or we turn it to an equation, right? That's the first thing we did by having it equal to 0. And then whatever the constant term is, we would take it to the other side by doing the opposite. So because we were adding 10, we would subtract 10 from both sides. If we were subtracting 10, we would add 10 to both sides, right? Now we have all the x terms, x squared, and the x term by itself. Once we have our a is 1, bear in mind our a is 1. It would be a little bit different when our a is not 1, and that's when we're going to move to example B. In this case, we realize our a is still 1, so we now have this part working with, and then we find our value that completes the square, which is 4. So we write it here, and then because we add 4 to one side, we have to add it to the other side as well. And this is just basically going to work out to say that if we had 10 units, we only needed 4 units to complete this square. It means that we're going to have 6 left over. So to reflect that, that is why we need to add that 4 to both sides. All right. And that's where we get that 6 here. Now we have a perfect square trinomial. This is a perfect square. This is a square number. This is also a square number. And then this is, well, let me not get into that for now. Once we have this, we're going to write it as a binomial square. That is what we have right here. And then you could choose to leave the minus 6 over there, but we're not going to leave it there, as we're going to take it back to have everything on one side. And then this is how we complete this square. And this right here is equivalent to all of this here. If you were to extend the bracket here and do this, you should get back this. And this is where we have it written in vertex form. Okay?